Let's now move on to a very simple, fundamental characterization of the copulus that we will be dealing with in this section. We are focusing on copulus from two families, two elliptical copulas and two Archimedean copulas. I will introduce the basic parameters of these copulas. The parameters are divided into two categories. Parameters related to multidimensional copulas, specifically those with more than 2 dimensions, and parameters related to bivariate copulas, which model the dependence between two variables. First, the Gaussian copula has a parametric input in the form of a set of parameters embedded in a d-dimensional correlation matrix. This matrix is symmetric. As a result, the number of correlation coefficients needed to describe the copula is smaller than d squared. Specifically, it is equal to 1/2 times d squared minus 1/2 times d. For the bivariate Gaussian copula, the required parameter is simply the correlation between the two variables, meaning a single correlation coefficient. When it comes to the student's T copula in its multidimensional form, it requires the same type of information as the Gaussian copula, a d-dimensional correlation matrix, where the correlation coefficients lie within the closed interval between -1 and 1. Additionally, unlike the Gaussian copula, the student's T copula requires one more parameter, denoted as nu, which must be greater than 0. This parameter corresponds to the number of degrees of freedom. For the bivariate student's T copula, as in the case of the bivariate Gaussian copula, a single parameter is needed to describe the copula, the correlation coefficient between the two variables. Additionally, the previously mentioned nu parameter is also required. Now, regarding the first of the Archimedean copulas, the Clayton copula, both in its multidimensional and bivariate forms, it is described by a single parameter, theta. This parameter takes values in the open interval from 0 to positive infinity. The same parameter, theta, is required to construct the bivariate Clayton copula. As for the Gumbel copula, the second of the Archimedean copulas, in its multidimensional form, it also requires a single parameter, theta. However, this time, the parameter belongs to the left closed interval from 1 to positive infinity. This parameter is also necessary for defining the formula of the bivariate Gumbel copula.